Hello, time for the next video. This is lesson 3.3, Inequalities with Multiplication and Division. And let's take a look. By the way, I know I'm doing a lot of this on paper and pencil. Let me know if this is causing you any issues, like if you can't see my handwriting or something like that. All right, or not see it, but understand it. Inequalities with multiplication and division. The steps use isolate, opposite, both, or IOB to solve as you would with an equation, okay? I would like for you to see the properties on pages 191 and 193. I'll let you look at that on your own. I'm going to try to shorten this video. I'm not going to actually graph each of these because we went into a lot of detail on graphing in the last two videos. Again, you will need to graph these when you do them as part of your homework. Okay, so I have an inequality here. The same steps are the same steps as an equation. So let's continue. So I have 3x is greater than 21. Okay, isolate the x by opposite operation. 3 divided by 3 is 1. 1 times x leaves me x. To both sides of the equation. 21 divided by 3 is 7. So my answer is x is greater than 7. Okay, let's go ahead and try this one. 5x is less than or equal to 30. Isolate the variable, opposite operation, divide both sides, divide by 5 to both sides of the inequality. 30 divided by 5 is 6. Rewrite the inequality symbol. X is less than or equal to 6. Okay, so see, the steps are the same as if this was an equation. Okay, see how it has a similar answer? The difference is in an equation is telling you what it is. With an inequality, it's telling you that x is greater than 7. The equation is telling you that it is 7. So just showing you they are similar. Okay, use the similar symbol. All right, let's move on. So x divided by 3 is less than negative 2. Isolate the variable. Opposite operation. What's the opposite of dividing by 3? It would be multiplying by 3. Okay? The multiplication of 3 cancels the division of 3. So now I'm left with x. Or basically, I could say x over 1, but it just means, x. To both sides of my inequality. So negative 2 times 3 is negative 6. Rewrite my inequality. All right, continuing on, let's do this one. Isolate the variable, opposite operation, multiply times 5. 5 multiply removes 5 divide, so that would be x. Multiply the other side by 5, 4 times 5 is 20. Okay, so in most cases, it's fairly simple. Now there's one rule that's different. Now in the last lesson I taught you how to add or subtract. Now with addition or subtraction, it didn't matter whether you were adding or subtracting a negative or a positive. If there's a negative and you added it, then it just sort of eliminated the negativeness. Okay. However, with multiplication or division, there's one rule that is different with inequalities than it is with an equation. And that is, if you multiply or divide by a negative, you have to switch your inequality symbol. Let me demonstrate. So I have w divided by negative 2 is less than or equal to 2. So I want to isolate the variable by opposite operation to both sides of the equation. Now I have negative 2 here, multiply, and I have negative 2 divide. They cancel each other out, leaving me with positive w. But wait a second. Didn't I have a negative attached to w just a minute ago? Well, that negative is gone because it is now canceled out. Sorry, I'm just going to turn this down. So now, let's go to the other side. I have positive 2 times negative 2 is equal to negative 4. Well, wait a minute. Didn't I have a positive before I started this process? And now it changed to a negative because I divided it by negative 2. So the inequality symbol, because of this negativeness being thrown to the other side, has to switch. Now you'll notice in the first one, in the first problem, the negative was on the left side, meaning that this was smaller, and the positive was on the right side, meaning this was larger. But now that I'm done, the positive answer, or W, is on the left side, and the negative answer, negative 4, is on the right side. Okay? So you have to switch your inequality. See how I completely flipped it in the other direction, okay, when I wrote my answer. So when you multiply or divide by a negative, then you have to switch your inequality each time. Now I said here to check the answer. So I'm just going to check this just so that we can make sure. Instead of W, I'm going to substitute W's solution. Negative 4 divided by negative 2 is less than positive 2. Less than or equal to positive 2. Okay? Now, let's compare. Negative 4 divided by negative 2 is positive 2. Now, in this case, then I would flip my inequality, and you can see, let's see if the statement is true. Is 2 greater than or equal to 2? Well, yeah, it is. Okay, so I just want to show kind of like, by checking the solution, it helps you to see what can possibly happen. Now let's try this with a multiplication problem. Negative 9 times y is less than or equal to 63. Isolate the y by opposite operation. In this case, I'm dividing. I have negative 9 divided by negative 9, which equals positive 1 times y. So I now have positive y. Positive 63 divided by negative 9 ends up being negative 7. Now look, what was positive is now negative. What was negative is now positive. So therefore my inequality, which is saying smaller on this way, now has to change to greater on this way. Okay? So let's check with the solution again. Substitute instead of y, I'm going to put negative 7. Okay, so let's solve. Negative 7 times negative 9 is positive 63. Positive 63 divided by negative 7 is negative 9. And negative 9 is definitely less than 63. Okay. But for our purposes, the negativeness moves to the other side. I don't know why it's not coming out the way I want it to on the check here. I'll refer back to that later. But hopefully, you got this lesson. So just remember, if you're multiplying or dividing both sides of the equation by a positive integer, then do it just like you would an equation, and the sign, the inequality sign, stays the same. If you're multiplying or dividing both sides of your inequality by a negative integer, then switch the sign to its opposite. For example, if it's greater than, switch it to less than. If it's less than or equal to, switch it to greater than or equal to. Okay, thank you very much.